I'm just going to give it a minute or two to see if people will trickle in from other sessions. Hi, Kai. Hi, Ethan. Hi, Tala. How's it going? Hi, Denny. I guess we can start with a question from the chat. What is your favorite NFT that you all like? See if anyone has any. Oh, cryptic cactus. I don't know this one. Repliccoin needs to happen. I don't know who will be in charge of that, but that needs to happen. Awesome. Okay, sounds good. I guess I'll jump right in. I'll introduce myself. Hi, everyone. My name is Laura, and I'm currently a software engineer at OpenSea. I'm in the product team, and I joined about 3 months ago. But I'm incredibly honored to be here, actually, because I was an intern at Replit last summer. So I feel like it's two worlds colliding. And today I'll be showing you how to write and deploy a contract, an NFT contract, directly on Replit. So when I started learning how to code NFT projects, it was actually right before Replit had rolled out their Solidity template. And so I really appreciate now the kind of how streamlined it is and how quick and easy it is to deploy contracts on Solidity on Replit, because I got to see the pain of actually trying to do it locally and try to learn from different tutorials. And it was definitely a pain. So I'll show you the quick and painless version of it, which shout out to Soren and Alex and Tyler. I know they've been working on this Solidity template. It's really, really streamlined. So hopefully you'll have a better time than I did when I started learning how to code NFT projects. And so we'll just jump right in. I'll share my screen and we'll start coding on Replit. Let's see how I can share my screen. Okay, let's go to this one here. Okay, I hope you guys can all see my screen. What we'll do is we'll start with this plus button here to create a template or create off of a template. And so I'll search for the Solidity starter. I'll just call it Replicon. And I'll make it private so you guys can fork it later. So once we create this REPL, it'll take a few seconds to kind of get things up and running. And the first thing that I will probably do is I'll just run the run button, which is what they also suggest as well. And I'll just, as a heads up, I don't know how much experience you guys all have with Solidity, but Solidity is a language, the programming language used for coding NFT projects. So you're able to kind of code whatever you want within an NFT contract. And I'll also talk through some terminology as well, which is useful. I didn't know this before coding NFT projects or diving into NFTs in general, but basically there's this concept of a collection of NFTs. So a collection of NFTs are NFTs that are all kind of related to one another and they're part of a single contract. And so if we talk about collections or if we're talking about contracts, those are kind of, that's the terminology. And also a token ID is referred to as which NFT within that collection is that singular NFT. So we'll be talking about token IDs that span from 0 to how many ever NFTs are inside of collection. So those are the things that are useful to know. I didn't know that NFTs had to be part of a collection. I just thought they were all kind of spread out. So it's really interesting to know. And I thought that we could actually dive right into a type of just a sample NFT that we'll code together. And I thought it could be fun to do something based off of real life. So the idea I had with coding with you all is for Cards Against Humanity, making it an NFT. If you're not familiar with the game Cards Against Humanity, it's a really fun card game. There are several cards that are either black or white. And the black ones have questions on them. The white ones have answers. And everyone goes around and they draw a question card one at a time. And everyone else has to kind of submit that what answer they think is the funniest answer based off of the cards that they have in their hand. And then the person who decides which one is the best question or the funniest answer is the person who drew that question. So it's a really fun game to play in person, but I thought we could make it a fun NFT project. So the idea here is that it'll just each card will be its own NFT, and if we deploy this contract to the mainnet, we'll actually be able to see it on OpenSea or other places, and it'll be like this real NFT that people can actually buy and sell. So very cool. Thanks. And the idea with this one as well is I want to invite you all to truly think about ways of adding to this project. I think the base thing we'll be doing today is kind of simple, actually. I really wanted to make it as inclusive as possible. But I would love to see what ideas you can do with this, moving forward, and making sure that, you get creative with it. Maybe, I don't know, maybe there could be like this game that is a crypto game that uses the fact that people own these cards in the future. So who knows? There are lots of things that we can do with this. And another thing that's worth mentioning is before the session, I actually went ahead and generated the images that will be attributed to each NFT. I'll actually go ahead and show this. I think Replit is I think Replicon is like overloading the servers probably. So I will go ahead and show the NFTs that I generated, just so you have a sense of what it looks like and what we're going to be working with. So let me go ahead and share a different tab over here. So this is a question, this is an answer NFT that I generated using SVG. I can share later the script that I used to generate these. A kind soul on the internet displayed all of the possible strings of each of the cards. And I think there are 5,000 of them or something. So I just generated a script that loops through all of them. And then they generate the SVGs according to kind of a format of what it's supposed to look like on a real card. And I'll show you another one as well that we have open here. This one here is a question card. So you can see the blank as well as something that will be inputted using the answer card. So this is just to give you an idea of what it's supposed to look like. And I already auto-generated these, and I uploaded them to a place called the Interplanetary File System. It's called IPFS. And what it is, it's just a decentralized file system. So if you upload anything to it, any file at all, it'll actually live on several different computers. And it means that you can just get a link to it and just access it directly from any place. And so you can actually hard code that link that you generate through IPFS and actually just hard code it directly to your contract. I'll show you how to do that in a second. And yeah, that's the kind of idea behind this Cards Against Humanity NFT that we'll be coding together. So let me actually go back to the REPL. Okay. So the interface isn't loading just yet, but I will go ahead and start coding the contract that we'll be doing together. The meat of the code will actually just live in this contract.sol. It's a Solidity file within REPL, and I'm just going to delete this whole thing right now, and then we can start coding it together. So the first line that I didn't actually the first line I didn't delete is this Pragma Solidity 082, which is just defining what Solidity version we're going to be working with, and the compiler can know in order to compile it. So let's go ahead and start coding the actual contract. So the interface for this is contract Cards Against Humanity, which is what I'm calling it, is ERC 721. And before we actually start doing anything, I kind of want to import a Open Zeppelin package. I'm just copying it over from another file that I have here. And what this does is it allows me to access the interface or the protocol of what an NFT should look like in code. And I can override certain functions. I can add functions, whatever I want. And this kind of reminds me of like a object-oriented way of being a child of an ERC 721 instance that Open Zeppelin makes available. So this is a pretty neat way of doing it. And ERC 721, if you're not familiar, is just the name of the protocol of non-fungible tokens. If you're curious, ERC 1155 is for semi-fungible tokens, and ERC20 is for completely fungible tokens. So I recommend taking a look, opening up the Open Zeppelin protocols and seeing what they look like, and what kind of templates they have, what kind of protocols they have. But we don't have to worry about any of that. They worry about it for us. I'm just going to call the constructor here, called ERC721. And it takes two parameters. The first one is the name of our contract, or the name of our NFT. And I'm just going to give it Cards Against Humanity. And the second one is the symbol. And I'm just going to call it CAH. And we can actually add more code here, but we don't necessarily have to. But if you wanted to do something upon within the constructor, we could actually add logic here. But we're not going to do it. So the other function we're going to write as part of our contract is called the Mint2 function. So the prototype for it is Mint2, and it takes in an address of a recipient. And an address is just it's a way of storing what is a wallet address or a address of a contract. And this is the only parameter that this function takes. And we call it a public a function because anyone can actually call it and actually get this information and do this action. And we say that it returns a uint of 256. Uint is just an unsigned int. It's just a number that can never be negative. So we like this because tokens shouldn't be negative. They just should span from 0 to whatever. And so what we'll do is we're going to call a function that is imported from the Open Zeppelin package that we just imported on line 4. And we're going to say safe mint the recipient. And we need a token counter. Like the first one is going to be 0, but we need something, a way to store this token counter as we're calling mint, as the client is calling Mint2 from this contract. So if we go ahead and create this, like we can store this number in a variable and we'll call it uint256. I'm just going to call it token counter. And I'm going to set it to 0 at first. And as we're calling Mint2, we want to increment this number. So if we go ahead and increment it, that solves the problem. But as you remember, the kind of prototype of this function, it requires us to return a uint256. This is just for the purposes of the client. It's just the way that the protocol, whoever wrote this protocol of what ERC721 should look like, determined that this is what it should look like. So we still need to return a value. And we can't quite return token counter without doing anything with it because it's already been incremented. So it'd be wrong to say, oh, the token counter is now 1 as a return value for the Mint2 function. So I'll go ahead and I'll store in another uint256 what the token ID minted is before we actually increment it. And so then by the time we actually have to return something, we can just return the token ID minted. And this is honestly the majority of the Mint2 function we'll be writing. It's as simple as this. It's just leveraging the functions that are given to us in the protocol or adding our own logic, whatever we want. Here we can even, if we only want to mint to a whitelist of people for some reason, we can add logic about this. We can add logic that we only want to mint to every other person. Like there's ways we can do whatever we want with this, but this is the most standard way of doing it. And then now you might be asking yourself, well, there's something wrong with this function still because it can just mint forever. There's no kind of guardrails on how many assets are included in this contract. So let's determine a cap, like a max number of cards that will be available. So I have here a number of cards 10, but it could easily be whatever arbitrary number you want. Just keep in mind that a uint256 is called 256 because it only holds enough for 2 to the 56 to the power of 256 minus 1. So just be aware of that. I don't think you'll ever get to that number, but just to be careful. And what we'll do is before this Mint2 function, at the top of this Mint2 function, we can do a checking. A very standard way of checking is using this require function. And it takes 2 parameters. It takes a Boolean and it takes a string. So if the Boolean is false, then it'll error out and it'll show the string to the user saying this is an error. And it's neat actually because it actually rolls back all the transactions or all the codes, all the lines of code that have happened before this require function. And so it's pretty cool because it makes the whole function atomic. What that means is if it fails for whatever reason, then you can actually roll back and pretend it never happened in the first place. So this is very useful for when there's lines of code before the require. Maybe you're changing some things, you're changing the counter, you're changing who you're minting to. It'll just pretend like nothing happened. So this is very useful to know. And the bool we'll be passing in is whether token cards is less than number of cards. This just takes care of the fact that we don't want the token counter to exceed the number of cards. And the second parameter we'll have is just a string. I'll say all tokens have been claimed. This is the entire, Mint2 function. Oh, the interface loaded here. I'll explain what the interface means and what this is, but this is super cool. I'll get back to it later. Okay, and now the other function we'll want to code is the is question function. And this is now more unique to the Cards Against Humanity function. Just out of curiosity, if you're curious, this function actually can be deployed as is and will work. This is completely working right now. And this contract is ready to be deployed, but it's still too basic for my desires. I still want to have something a little more Cards Against Humanity-y within the contract. So what we'll do is we'll allow an interface for people to call a function called isQuestion, and I'm going to write it down here so you have an idea. And what this will do is it will just allow someone to input a token ID, and it'll spit out whether it's a question card or an answer card. And this will be useful because if people build on top of this contract, maybe they build a game that uses the fact that the assets are NFTs, the cards are NFTs and they have ownership. And maybe they want some logic around, if it's a question card, I'll do this. If it's an answer card, I'll do that. Anyway, whatever people want to do, they are able to kind of leverage this function that we're writing as part of the contract. And so it's completely immutable. And this is pretty cool. So we get to do this in Solidity. So it takes in a uint256, which is a token ID, and we call it an external function. And the keyword view here is really interesting. What it does is we tell the compiler, look, this is a function that will only view information. It won't actually modify anything. And this is important because in Ethereum, the entire logic around viewing information versus modifying has different costs and has different paths that it takes. So I'm oversimplifying it, but it's useful for you to kind of determine or tell the compiler, look, this is a function that won't be touching anything. It will just look at it. So this is called a view. And what we'll do is it returns a bool. Oops. Okay, here we go. And we'll do a very similar check for the require function. But instead of all tokens have been claimed, we can say something like non-existent token ID. And so the next thing we want to do is we want to loop through an array that we're going to create right now and check whether the ID is part of that array. And so the array that I'll be creating is, and the way you do an array in Solidity is just using this syntax. And I'm going to call it question cards. And what I'm going to do is I'm just going to hard code the IDs of the cards I know are question cards within the IPFS. So for context, I really wanted the questions and the answer cards to be all scrambled when I uploaded them to the IPFS. And so what we'll do is I actually, like, because they're so random, they're not all in order. They're not like 0 to 5 are question cards and 6 to 10 are answer cards. They're all kind of scrambled. So I went ahead and I checked which ones are question cards and which ones are answer cards. And I found out that the question cards are 0, 2, and 4, and 5, which means that the answer cards are input. Like if you deduce, then they're 1, 3, 6, 7, 8, 9. And so with this, again, just recapping, the token ID of the 0, or token, the NFT of token ID 0 is a question card, and the token ID of 1 is an answer card. So that just allows us to kind of write this function, the is question function, for future reference. So we're hard coding it all into this function, or to this contract. And then we can go ahead and write this for loop that loops through the entire array. It's very similar to JavaScript as well, as you can tell. So I'm just going to say if question cards at this index is equal to the token ID, then I'll just return true. And if we get to the bottom or the end of the for loop and none of the question cards are actually the token ID, then we know it's not a question card at all. And we don't actually need an answer card array, because this is just like we can deduce from the question cards, and we know that the number of cards total. But you know, obviously, if you change this to a higher number, we'll have to add more of those question cards and answer cards. And so yeah, so the final thing we're going to do is we're going to write a override function. I'm going to show you what that means and why this is important. So I'm going to override the function base URI, which is an internal function, which means it's only called by internal contract things. It can't be called externally. And it's a pure function because it doesn't modify or read information from what's being stored. So it not even reads it. It just is a pure function for that purpose. It's an override function because it already has been implemented by the Open Zeppelin contract protocol, but we're going to override it with our own information. And it returns a string memory, which is just a fancy way of calling a string in Solidity world. So what I'm going to do is I'm going to copy paste the URL, and this is actually a live URL if you want to check out, which points to a JSON object which includes an image URL of the SVG that we generated, and I showed it to you previously. So what I'm telling this contract right now is, hey, whenever you're generating or spitting out the token URI of what the NFT metadata is, please use as a base URI this repository, like this place. And what it'll do is, depending on what the token ID is, it'll just tack it on to this URI. And I'll show you what that means when it's actually deployed. The Replit interface will actually show you what it looks like. But I'm just telling them, hey, this is where my tokens live. My metadata for the tokens live. So without further ado, I think this is the kind of end of the coding of the Cards Against Humanity contract. This is it. It's as simple as this. There's no magic to it. If you want to read more about the difference between these prototypes, they're very interesting and very useful to know. But if you know how to code other things, you can definitely learn Solidity. It's very accessible. And I think we're ready to deploy. So what I'll do is I'll connect my wallet. And you might not be able to see this because I'm signing. There's a MetaMask pop-up that just popped up. And I was able to now confirm that I want to connect my wallet. And I want to, and oh, by the way, this is interesting to know. I had previously checked out the Replit testnet, which is actually something that Replit coded themselves, which is very, very cool. Other testnets you might have heard of are Rinkaby, for instance. There's also Robskin, and Replit created their own testnet, which is very easily integratable to Replit directly. So highly recommend using that, especially if you're using Replit. And they allow you to get 1 ETH for testing. So it's free ETH, basically, like a fake ETH, for you to add to your testnet MetaMask account. And so you're able to have 1 ETH to just play around with. And this is really cool because other places you might have to go through many hoops to find fake ETH, basically. And here it's just a click of a button away. So I highly recommend This is really a really cool feature. And what we can do, it's as simple as just clicking deploy. So I'm going to click deploy, and you're also probably not seeing this now, but there's a MetaMask kind of pop up right now that's telling me, hey, this is the amount of money it'll take, but it's all free money anyway. So I'm just clicking confirm. And right now it's deploying. It might take a few seconds right now. I'm just going to hop over to the chat to see if I missed anything. Let's see, it's still deploying. Okay, there we go. So we now have this interface, and I'll give you kind of the if this is too magical for you, let me explain what this interface is. It's basically just a website. If you see at the top, this is the actual HTTPS, and I actually think you can actually access this. Let me send it to the chat. Let me know if you can access this, but it's a real website that created an interface that communicates with the contract directly. And it has all of the functions that, you know how I told you that the Open Zeppelin contract has all these functions already kind of done for you, and you can even override them, or you can kind of call them. And so you can see that there's a whole host of like traditional functions that are unique to NFTs. And even the one that we wrote together, which is not part of the Open Zeppelin. This is like a very Cards Against Humanity question or function that we wrote together. It's also part of this list. So this is pretty cool. It provides all the interface for this function. And the exciting thing now is I get to kind of mint a Cards Against Humanity NFT to myself now. So let's go to Mint2. And I'm going to get my address. I'm just copying it over from MetaMask. And this is my address. And I'm just going to call run, and it'll probably, okay, now it's just asking me to confirm on MetaMask. But this means that it has been successful because the transaction hash has been outputted. So this is very exciting. It actually, I don't think you can see this, but if I go to my MetaMask personally, there's a pending transaction that's like, hey, there's a REPL, testnet transaction that is happening right now, and you are about to get an NFT. So this is really exciting. It's a real thing that just happened. And you can even check out the other functions that might be interesting. So let's check out the name function. It just spits out the name of the function, which is what we used in the constructor. If we go to symbol, we can run it, and it also spits out that thing. We can go to the token URI and enter, the first token obviously is 0, so that's the one I have. If I run it, I get the Pinata link as the URI. And if I copy paste it for you, here, one sec. Okay. You can't see another tab of mine, but I'm just going to show you what it spits out, which is, remember, it's the entire Pinata IPFS directory, and it attaches that 0 because the first token that's ever minted is a 0. And so it's all because of this base URI function that we overwrote. So, and if we see owner of, we can also check out what it spits out. I want to see who the owner of 0 is. Let's see. And it's my address, 8DB. So this is all working as intended. Just out of curiosity, what does 1 spit out? We haven't minted 1, so maybe there'll be an error, or maybe they'll have a more elegant way of doing this. Yeah, as I expected, there's a reversion of the contract because the owner is for a non-existent token. Since this hasn't been minted yet, we don't know what the owner of 1 is, which is expected. So this is what we actually intended to do. So that's all I have time for today. But thank you, everyone. Would love to see what creations you have for this project. Please fork it, please remix it, build on top of it. And yeah, I'm excited to see what projects you have. Bye, everyone.